Good morning everyone. Today I am going to discuss a topic with you which will find an easier method of getting a matrix polynomial. But practically when you see like that, suppose A is the square matrix given, you prove that AQ minus 7A square plus 6A plus 9 equal to 0, 9I equal to 0. That kind of proving most of the students, even myself, try to avoid, because finding AQ for a 3x3 order matrix is time consuming and there is no innovation in multiplying a matrix by 3 times. Here I am going to discuss one concept with you where by using a theorem you can get the matrix polynomial very quickly. You will say, sir, is this in syllabus? It may not be in syllabus, but when you are appearing for other examinations, any examination, math-based examination will help you a lot in +2 courses, where you can minimize your time in compared to other competitors. They will take 10 minutes to solve it, and by learning this you can solve the sum in 1 or 2 minutes. Okay? The theorem I am going to discuss with you is written on the board, that is called Cayley-Hamilton theorem. I think all of you can see the board. This is not included in your normal coursework, but very useful for all the exams, even MCQ technique in your board exam. When you are solving, when they have asked you to prove something with the help of a matrix by squaring or by cubing, then this Cayley-Hamilton theorem will help you. Try to know what is Cayley-Hamilton theorem. This Cayley-Hamilton theorem states that every square matrix satisfies its characteristics equation. What is a characteristic equation? Suppose I have a square matrix like A equal to 2, 3, 1, minus 1. Here the characteristic equation going to be its characteristic equation is A minus lambda into I equal to 0, where lambda value you have to find. A is this matrix 2, 3, 1, minus 1, and its determinant. So determinant of this matrix you can write this manner, equal to 0. So this will give you determinant of 2 minus lambda 3, 1 minus 1 minus lambda equal to 0. If you simplify it, it is going to be lambda minus 2 into lambda plus 1 minus 3 equal to 0. So this gives us lambda square minus lambda minus 5 equal to 0. This is the characteristic equation of this matrix. Now, what is the utility of Cayley-Hamilton theorem here? The theorem states that this square matrix will satisfy this equation. Okay? So, by Cayley-Hamilton theorem, we can write A square minus A minus 5 you cannot write because these are matrices and this number, so it will be 5y equal to 0. So you can get it very fast, that A square minus A minus 5y equal to 0. You don't have to find the square of the matrix or cube of it. Even suppose they have asked you to put this thing, a cube minus a square minus 5a equal to 0. That is also not. Because if I multiply by a, then it automatically comes. You don't have to multiply the same matrix by itself 3 times. A cube means a into a into a, no need to prove it. So in a MCQ question, they have given this matrix, then they are asking you, the matrix satisfies this equation, this. 4 options are given. You can get the answer very fast just by writing the characteristic equation and then put the value of a over here and the constant you replace by the unit matrix. Now I am going to show you the ease of calculation for a 3 cross 3 ordered matrix. If I take a 3 cross 3 ordered matrix, let's see how does it work. For Cayley-Hamilton theorem, let us take, let A equal to 1, minus 1, 2, 0, 1, 3, minus 2, 1, 0. Okay? They can ask you a question like that. For this matrix, say a cube minus 5a square plus 7a plus 8a is 0. Or 4 options they have given. This is very difficult to calculate in exam. So I will take the help of Cayley-Hamilton theorem here. I write the characteristic equation here. The characteristic equation is a minus lambda I is determinant equal to 0. The way I got previous one. This implies determinant to 0, 1 minus lambda 3. So this implies 1 minus lambda plus lambda square minus 3 plus 1 into 0 plus 6 plus 2 into 0 plus 2 minus 2 lambda equal to 0. So this will be changed to minus lambda cube plus 2 lambda square plus 2 lambda minus 3 plus 6 plus 4 minus 4 lambda equal to 0. This will give us, if I simplify it, then finally it gives us minus lambda cube plus 2 lambda square minus 2 lambda plus 3 equal to 0, or lambda cube minus 2 lambda square plus 2 lambda minus 3 equal to 0. Now the given square matrix will satisfy this equation. So replacing lambda by a, we have a cube minus 2a square 2a minus 3 equal to 0. See how easily I have got here. I just wrote the characteristic equation. From this characteristic equation, I got a polynomial. Then I converted to polynomial into matrix polynomial. So any higher power they are asking based on it, that also can be found from this Cayley-Hamilton theorem. So the matrix AQ minus 2A square plus 2A minus 3I. Sorry, I forgot to write I over there. I must be there because I is the unit matrix whose multiplication is necessary, because 3 means it's a constant. 3 into I you must take. Then after getting such a polynomial, and by Cayley-Hamilton theorem, I can tell you how to get the inverse also. To find A inverse, I tell you the method only. You keep the unit polynomial, that 3i on one side. Then 3i will give you AQ minus 2A square plus 2A, multiplying both sides by A inverse. 3 into I into A inverse is going to be A square minus 2A plus A into A inverse is how much? That is 2I1. So this gives us A inverse equal to 1/3 A square minus 2A plus 2I. Now from that given matrix find A square. A, I you know, substitute there, A inverse can be written. Okay. This part you can do by the previous sum method also, where you, previous concept also, where you really prove the polynomial, that you take it as the matrix, then multiply it by 3 times, and then go for finding the matrix inverse by shifting the other part on the right hand side, keeping the unit matrix on the left hand side, then multiply both sides by A inverse, then it naturally comes. Okay. But Cayley-Hamilton theorem will help you to decide this part very first. This polynomial in any exam, any MCQ exam, maybe your board or JE exam, wherever you are going, if they have asked you to prove this polynomial, you can get it very fast by using Cayley-Hamilton theorem. I think you are going to practice some sums like this. I am just writing it here. Just write for practice. Let the matrix A be 2, 1, 5, 2. Find the quadratic polynomial. Write the sum. Find the quadratic polynomial satisfied by A. Hence find A inverse. And the second question you write, let A equal to 1, 3, minus 1, 2, 4, 1, minus 1, 1, 2. Find a cubic polynomial satisfied by this matrix, and hence find A inverse. I think all of you can do it easily, so you must do it and submit your work next day. Thank you.